We are live. I don't know if anyone's on though. I'm checking Discord. Is anyone out there in chat? Say hi, please. Please, 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 please. Hello, hello. Well, if no one's out there in the chat, hopefully they can watch this video later. Um, Essentially, to find the domain, I'll just do a quick recap. Maybe someone will come on by then. But to find the domain, like a number one, whatever's inside of the square root, you just can't have a negative, and you only have to worry about it if it's an even root. So in this instance, that value can't be negative. So we say that the x squared minus 1 has to be positive, and that's greater than or equal to 0. Now that it's greater than or equal to 0, well, that's a quadratic inequality. We know how to solve quadratic inequalities. We just need to find the zeros. So that's 1 and negative 1. You put that on a number line. And we have to test true or false. So if I plugged in negative 2, negative 2 squared is 4. 4 minus 1 is 3. 3 is greater than 0. If I plugged in 0, 0 minus 1 is negative 1. Negative 1 is not greater than 0. And then if I plug in a value like 2, and 2 squared is 4, 4 minus 1, that's going to be 3. 3 is greater than 0, so that's true. So this value right here, that's what's going to be true. And so my answer is going to be from negative infinity to negative 1, union from 1 to infinity. And that's going to be my answer. Anyone else out there in chat? It says I have a few more viewers. So let's continue. Number 2, it's basically the same thing. We have to set it greater than or equal to 0. Let's look at number 3, because that one's just a tad bit more complicated. So it's an even root, so I can't have a negative inside of the square root. When it's an odd root, it doesn't matter. So like a number 2, this x, you just ignore it. It doesn't mean anything in terms of a domain restriction. It's what's inside the square root that's important. So for number 3, we have the fourth root of 16x over x squared minus 9. So it can't be negative inside of the square root. So we set whatever's inside that square root to greater than or equal to 0. Now it's a rational inequality. So with a rational inequality, we need to find the critical values and the zeros. So the critical values are things like what make you divide by 0. So my critical values, if I set x squared minus 9 equal to 0 and solve, you should get 3 and negative 3. And then my zeros, if you set the top equal to 0, your only 0 should be 0. Because that would be 16x equals 0. Divide both sides by 16. Get x equals 0. So we place those on the number line. Critical values always are open circle. And then our zeros depending on the inequality. So now we just need to go through and test true or false. I'm going to do the sign chart method this time. So I just factored the denominator. So if I plug in -4, -4 times 16 is a negative. -4 minus 3 is a negative. -4 plus 3 is a negative. 3 negatives means that it's negative. If I plug in -1, -16 times -1 is a negative. -1 minus 3 is a negative. -1 plus 3 is a positive, so that's 2 negatives. So that's a positive. If I plug in +1, 16 times +1 is a positive. 1 minus 3 is a negative. 1 plus 3 is a positive. So I have 1 negative. And then if I plug in 4, 4 times 16 is a positive. 4 minus 3 is a positive. And then 4 plus 3 is a positive. So the positive regions is my solution because it's looking for values greater than or equal to 0. Values that are greater than or equal to 0 are positive numbers. So that's going to be from -3 to 0, union from 3 to infinity. And that's going to be my answer. So those are the domains. The next part for this, it says use a calculator to help sketch and identify any vertical asymptotes and horizontal asymptotes. So if I wanted to use Desmos on this one, we just need to enter that into a calculator. Now, the way that I'm entering it into my calculator, it's going to be kind of weird. But I did, instead of just doing like a fourth root, what I did was I did it to the 1/4 power. It's just easier to do that because there may not necessarily be a root button. Looking at the different functions, it doesn't seem like there's any... Yeah, it doesn't seem like there's any values for us to be able to do that. So that's why it just took the function to the 4th power. So looking at this, it looks like I have vertical asymptotes here at -3, here at +3. So that's why, and even if you look at, like, that's what's in the denominator, right? -3 and +3. It may look like I have one here at 0, but the issue here is it starts going against what our domain is. So remember how we said that it's negative from -infinity to -3? Well, that's why from -infinity to -3, everything's positive. It's above my y value. And then it was positive from -3 to 0, so that was good. But then from 0 to 3, there's no more graph because that contradicts my domain. So because it contradicts my domain, it doesn't exist. And then from 3 to infinity is the rest of it. So there was no graph from -infinity to 3, and there's no graph from 0 to infinity, or from 0 to 3. So it kind of validates our domain that we have, that we created there. It doesn't look like there's any... There might be a horizontal asymptote right here. So whatever this value is. So it looks like, what is that, 4? But it's kind of hard to determine that. Maybe it's actually 0. It's just going to approach 0. No, looks maybe... Is it going down as it goes to infinity? Maybe it's a half. It gets really weird when we start dealing with like roots. So if you guessed that the horizontal asymptote is going to be a half, That's fine. You're just going to have to use your calculator and go on to infinity to be able to determine that. So that is a weird one. Any questions on that? But that's also why I said use our calculator for it. You know, that's not something that we can just easily discover. Okay, so let's move on. So for number 4, it says sketch the graph of y equals g of x by starting with the graph y equals f of x and then transform it. So all you have to do is recognize what this parent graph is. You can do that by entering it into Desmos. Good thing I canceled out Desmos, right? Makes things much easier. And if we know what our basic transformation of functions are, then the rest just basically creates itself. So for example, my parent function, so I'm going to do that to the 1/3. Now this is always a horizontal shift and that is a vertical shift. So you're going to see it move over 1 and then it's going to move down 2. So that starting value, which is originally at 0, 0, moved over 1 and then moved down 2. Now to get that parent function, this wasn't a parent function that we memorized in the beginning of the year. So just enter into Desmos to kind of take a look at what that's supposed to be. You could also just create an XY graph and plot points to be able to construct that as another idea. But we should just be able to recognize that that's a horizontal shift and that is a vertical shift and it's going to move over. And we would do the same thing here. For a 1/4 root, so it looks like a square root function, but it's a little bit more, it's not as smooth. And so same idea without the shifting, starts at 0, 0, and then with the shifting it moves over 1 and it moves down 2. So it moves over 1 and moves down 2. Any questions on numbers 4 or 5? Okay. So let's look at some of these with positive exponents only. Let's do number 8. Number 8 looks fun. Let's start with number 6, and then we can do number 8. So I have 7 times 5 over x plus 4 times, now because this says x plus 4 to the negative 3, I can actually move that up into the numerator. So then this would be negative 1 times x plus 4 to the 3rd. And then this is x plus 4 to the negative 2, so I can move that to the bottom. And so that'll be 1 over negative 2 times x plus 4 squared. So I got rid of the negative exponents. Now I have an x plus 4. I have 3 x plus 4s on the bottom, and I have 3 x plus 4s to the top, so they're all going to cancel out. And then now I have 7 times 5 times negative 1. So that's going to be negative 35 over, and then I have a negative 2 on the bottom. So that's just going to be 35 over 2. Comments or questions on that one? All right. So on the next one, number 8, I have x minus 3 to the 1/3 times x minus 3 to the 1/3 over x minus 3 to the 1/7. So my first step is I converted the root into an exponent. So just remember whatever the root is, that goes in the denominator of your exponent. So since it was a cube root, it was 1/3, 7th root, it's going to be 1/7. Whenever we're multiplying, we add. So I'm going to get x minus 3 to the 2/3 over x minus 3 to the 1/7. And then now 2/3 minus 1/7. So we're going to get 7/7, 3/3. 14 minus 3 is 11. So we have to subtract the exponents, so that's why I did 2/3 minus 1/7. And so now I'm going to get x minus 3 to the 11 over 21. And you can leave it like that. As long as it's a positive exponent, we don't have to worry about it. Now we go back to identities. Oh, I have 2 number 8s. Whoops. All right, so let's look at this one. Let's do number 8. So instead of writing it out, because it'll take a long time to write it out, I'm going to make this side look like this side. So I want it to equal 2 sine alpha cosine beta. Now the identity for sine, that is a sum and difference identity. And so that's sine alpha cosine beta. The sign stays the same. And then cosine alpha sine beta. So that first one is going to be sine alpha cosine beta. Sine stays the same. Cosine alpha sine beta. The second one, so plus, then I get sine alpha cosine beta minus, and then it's going to be cosine alpha sine beta. Now, if there's anything that can combine, I have a sine alpha cosine beta, so that gives me 2 sine alpha cosine beta. And then the cosine alpha sine betas, those will cancel out. And so now I have equaled what I intended to equal. Let's look at number 10. So for number 10, it's tangent alpha minus beta. So immediately my identity should be tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. So I just need to find what tangent alpha is and what tangent beta is, plug it in, and then simplify. So for my alpha, so here's alpha, here's beta. So for my alpha, it says cosecant of alpha is 3. And it says between 0 and pi halves. So that's in quadrant 1, because this is 0 and this is pi halves. Cosecant is hypotenuse over opposite. So hypotenuse over opposite. Using the Pythagorean theorem, that's the square root of 8, or 2 root 2. And so the tangent of that, so tangent alpha, is going to be opposite over adjacent. For the beta triangle, it just tells us it. Tangent of beta equals -7. So now I'm plugging everything in. You're going to get 1 over 2 root 2 minus -7 over plus 1 over 2 root 2 times -7. Now from there, we just have to simplify it. You can enter that in your calculator, and you're going to get a decimal approximation. That is another thing we can do. The hint here would be finding the common denominator. So you're going to get 1 minus, so plus, because it's minus and negative, 14 root 2 over 2 root 2 over, and then on the bottom here, these multiply. So you're going to get 2 root 2 minus 7 over 2 root 2. Those will cancel out. And this is a good enough simplification, but you could multiply by the conjugate. So if we looked at that as -7 plus 2 root 2, you can get rid of that square root in the denominator. But that's a sufficient way of looking at it. And graphing sine and cosine, let's look at number 12. So y equals 3 cosine of 2x. So I have an amplitude of 3. I have a period change. So if I want to think about that, it's 2 pi over b. So my period is pi. My parent graph is cosine. So it's going to look like this. So then sketching the graph, we're going to have, I have to put the 2x, and I have to put that between 0 and 2 pi. Solving for x, divide everything by 2. I'm going to get 0 is less than or equal to x, which is less than or equal to pi. Finding all those values in the box. These are my x values. So it'd be 0 and pi. Add them together and divide by 2. Add them together and divide by 2. Add them together and divide by 2. I know I went a little quick on that, but if you were to just add them and divide by 2, that's how to find the middle of those. So now I know what to label my graph. So pi fourths, pi halves, 3 pi fourths, and pi. So it's going to start here, cross, go below, cross, go back above. And these values are going to be 3 and -3 because we have to have the amplitude. Is that it? I think that's it. All right, so we sampled every single type of problem here. If you guys do have any other questions, go ahead and post them in Discord. Other than that, before we go, are there any last questions? Great. Well, I hope you guys had a good weekend. I hope you guys have a good day. And we only have one more lesson in this section. And then, it's just going to be the study guide. Then we're going to review. over the weekend. We're going to move on to our last chapter. A lot of those lessons are very easy, so we may double up on a few of them just because, like I said, it's logs and exponential, and we worked on that in integrated 3, and it's nothing new under the sun. So thanks, guys. Have a good one.